Alrighty, I just wanted to go over that homework from last night. Mostly algebra review with a little bit of geometry sprinkled in there. On those Wednesdays when I can, I'd like to just do a little bit of review of algebra. So let's take a look at this first problem. The reason I put this in was number one, to make sure that you knew that you were supposed to take care of that +1 first, and then also to see if you knew to multiply by the reciprocal. So those are the two things for number one, making sure you knew to take care of the 1 first by subtracting 1 on both sides, and then also going over and multiplying by the reciprocal. If you try to divide by 2/3, that's fine as well. You just need to remember to keep change flip. On problem number 2, this was variables on both sides, but I wanted to have one side that just had variables on it. Even if this, I taught you guys when you're trying to figure out which side is variables, you can look at the coefficient of x, and whichever side has the bigger x for the coefficient, run with that side being variables. In a case like this, even if that 2 was smaller than the number on the other side, you would still go over and call that side the variable side because all it has is variables. So it only makes sense to have that being the variable side. So you can see I added 3x to both sides and then I divided by 5 to get x equals 2. Always remember what you're doing when you're solving an equation. You're trying to figure out the value of x that would make this equation true, and that would be the number. Now on number 3, this is a quadratic, and this one ends up having two different numbers that would be solutions, or two different values of x that would make this equation true. I didn't know if you were solving by quad formula or by factoring, so I did both. Either way, you end up getting -2 and -6. If you substituted either of those in, it would make the equation true. Now on number 4, when you cross multiply here, you end up getting the 2x plus 10 times 3, and you needed to remember to distribute. Then you would have 7x on the other side. So when you solve, you subtract your 6x from both sides, you end up having x equals 30. And you could check your answer by substituting back in as well. Now, if you didn't realize that you should cross multiply, you may have multiplied by 7 on both sides. That would work as well. You would probably just end up with fractions, which would be a little confusing. Now on number 5, I like to write out the basic form. It's kind of like when we were trying to find the area of those wacky figures, and I said like rectangle plus half circle plus triangle. I always break things down to the basics. So this problem on number 5 is cost plus tax equals total. Then I put in the cost, which is $25, and then I said tax is 9% of $25. You need to know that 9% is not 9, it's not 0.9, which is 90%, it's 0.09. So when you multiply 0.09 times 25, you get $2.25 for tax. A lot of times kiddos forget that they have to add the original cost as well, and you end up with $27.25. Now on number 6, it says an item costs $32.50, but there's a 10% off discount. So what I did was I figured out what the new price was. 10% is always rather easy to calculate. You just move your decimal point once to the left or multiply by 0.1. That gives you $3.25 off. The new price is $29.25. At that point, I'm going to go ahead and add 8% of $29.25. A different way you can do this is take $29.25 and multiply by 1.08, which is basically multiplying by 100% and 8%, and that would give you your answer of $31.59. Now on this problem right here, it was set up for elimination, so that's what I did. I can't think of a good way to do substitution. I think you'd end up with ugly fractions if you got any of those or either of those equations in x equals or y equals form. So I just solved for one variable, y, and I got 14/29. I actually messed up the first time and I had to go back and retry, but I got 14/29. And rather than substituting that in and solving for the other variable, I decided just to start the problem over and get rid of y. And when I did that, I ended up with x being 110/29. And that would be the x and y combination that would make both of the equations, also known as the system, true. Okay, Now, this is a complex problem. These are all pretty much not one step problems, but very direct problems. I wanted to give you a challenging problem that you would have to really think through and maybe draw a picture. So the concept here is, as you are turning in a circle, the inner wheels will be having to travel a path that is shorter than the outer wheels, as can be seen with our diagram over here. You can see that is a smaller circle for the inner wheels to go, and it's a bigger circle for the outer wheels. Now, how this works is cars are set up with a thing called a differential. And what that does is it makes it so that the inner wheels and the outer wheels, or the left wheels and the right wheels, can spin at different speeds. If you didn't have this, then the car would have a lot of issues because one tire would need to rotate more than the other tire. Now, we'll talk about this later, but basically a train does not have a differential. So both tires have to move at the same exact number of revolutions. It's kind of a cool thing. We'll talk about it in class. But for this one, we wanted to figure out how many extra rotations did the outer wheel need to go. Obviously, you'd have to do more rotations because it's passing a further distance. So what I did was I drew it, and I found out one had a radius of 40 feet and one had a radius of 48 feet. That being the 40 feet and then the 8 feet, which was the distance between the tires on the car. So you end up getting 96 pi feet versus 80 pi feet. So if the only thing the question asked was how much further did the outer wheels need to go, the answer would be just subtracting them, and you would get 16 pi feet further. You could also convert that to approximately 50.265 feet further if you didn't want to have the pi, or multiply that by 12 to find out how many inches. 603.1858 inches. Now, what I did was I figured out what the distance a tire would go rotating one full time. Well, that's just the circumference of the tire, and I found out that that was you still use the formula 2 pi r or pi d, so it'd be 32 pi inches per rotation, or about 100.53096 inches. Now, when you figure out how many rotations that is, you say, well, the distance was 603 inches further, and then each tire rotation would be 100.53 inches, and you get 6 extra rotations. If you did not want to convert to inches, you could have also done, or if you didn't want to get rid of pi, you could have done 16 pi feet times 12 for inches in a foot, and you get 192 pi. And you could divide by that 32 pi. The pi's cancel, and you end up getting 6 extra rotations. All right, hopefully that made sense. Thank you so much for watching. Let me know if you have any questions, or talk to the sub if you have any questions on this.